Okay, ready to go. I'll do this without speaking. Try to anyway. Without speaking. So I've got... Now multiply each of these by the 9 to put it in standard form. 9, 9, 9. Okay, what about, what do I get here? 9y. Then add the 8x to both sides. And you get 8x plus 9y equals negative 18. Okay, perpendicular to this, we got to figure out what our slope is. So if it's perpendicular to this slope of -2, then it's going to be 1/2 times -2/1. So the reciprocal of -2 is 1/2. And one of them has to be negative, and the 2 is already negative. So we've got, this is our slope. M is 1/2. And through this point, so I've got y plus 3 minus 3. Okay, we'll subtract the 3. And I've got y equals 1/2 x minus 3/2 minus 3. So this is a part we made some mistakes on. This is really 3/1. So I have to add these two up, these two negative numbers. So let's see, get our denominator to be the same, multiply this by 2/2. So this side here would end up becoming, what, -3, this is -6 here. And this is -3, so it's -9/2. So I end up with y equals 1/2x minus 9/2. Adding or subtracting fractions right here. Got to remember to do that in the context of a problem. Okay, here, here. So we got parallel to y equals 7. Well, if we're figuring out what the slope is, if it's parallel to y equals 7, well, one of two ways here I could look at this. It would mean what? Let's see, here's a little graph here. If this is 7 and this is y equals 7, then if then parallel to y equals 7, that means it's another horizontal line going through this point of -3, -8. And -3, -8 could be down here somewhere. And then I can see that my equation here, if it's parallel to y equals 7 up here, these are parallel to each other, this equation would be y equals -8. Alternatively, we know the slope of a horizontal line is 0. This slope of y equals 7, if it's parallel to that, then it's going to have the same slope, and the slope is 0. So if m equals 0, I could write this equation out to be what? How about y minus 7 equals 0, the slope, times x minus -3. Minus -3, which would be +3. Okay, and as you can see, if I'm going to figure out what's going on here with this problem, through -3, parallel to y equals 7, so that's my slope. Oh, but it's -8, not -7. I want this ordered pair. So this would give me +8. That's better. So now when I go to figure out my equation, I'll subtract 8 to start. And this y would equal, this is 0, of course, 0 times up to this point is 0. So I have 0 minus 8. And y equals -8 would be my final solution. So either one, drawing it out and then seeing, comparing the two slopes. Okay, next problem. Okay, number 6, determine whether the relation is also a function. Remember, all the x values have to be different for it to be a function. So I'm going through, I got -2, 3, 6, 9, 10. I did not repeat the same number. They're all different. So this one is a function. Find the function value, using our functional notation. I'll substitute 4 for the x in the equation, and I will get 2 times 4 to the second power plus 4 times 4. Put them in parentheses. So here I've got 16 times 4 to the second power, 16 times 2 is 32, plus 4 times 4 is 16. Altogether I get 48. F of 3, 4 times 3 to the second power minus 3 times 3 plus 7. This here is 9 times 4 is 36, minus 9 plus 7. Okay, so what have we got? I'll do this one. This is -2, right? -9 plus 7 is -2, and 36 minus 2 is 34. Graph this linear function. So I'll do that using the slope-intercept. So I'm going to start with 4 here. My slope is 3, so in this case I can go up 3, 1, 2, 3, and over 1. And I can use my straight line here to draw the line. Okay, that's about right there. Alright, so your graph should have looked like that. If it was out here further, that's wrong. If it's somewhere out here, that, going from, even from here to here, that's incorrect. It's got to be this line here. Whoop. Okay. Okay, object is thrown upward. You can read all this, and it ends up giving you the polynomial that we're looking for. Find the height of the object at t equals 5. So I'm going to substitute 5 for the t and then calculate that out. So I've got -16 times 5 to the second power plus 30 times 5 plus 534. Okay, then your calculator is good for this. So you end up with 284 feet. Here's another, find the function value. P of x equals this, q of x equals this. Find them when you add them together. So that means you're combining like terms. So what have you got here? I've got -3x squared. I've got -7x minus 8x is -15x. And -5 plus 7 is plus 2. Okay, that's when you add them together. Done. This one, the functions change, but the idea is to take and find q of x minus p of x. So I want to put the q of x first. So you got 2x squared plus 8x minus 9. And then we're going to subtract the -4x minus 1. We'll do it this way. Clearly subtracting this. Put my 1 there to help. -1 times -4 is +5. Put that underneath the like column. Put a plus sign if you like. -1 times -1. Oh, wait a minute here. negative 1 times negative 4x. This is, what am I doing here? Negative 1 times negative 4x is positive 4x. So that's going to go here. My mistake. I don't want this now. I want negative 1 times negative 1 is positive 1. We'll do it that way, which is the right way. 2x squared plus 12x minus 8. Much better. Okay, I'm subtracting p of x from q of x. Number 13, find the domain of this rational function. So I can have all real numbers except x cannot equal 3. Okay. Next. Okay, here we'll graph the solution set of this inequality. So x is greater than 4. So here's 4. My line going this way, all the values that are greater. At the 4, I'm going to put a parentheses because of the inequality without the equal sign. And my interval notation, therefore, is going to be parentheses 4, comma, infinity, and close parentheses. This one here, all the x values greater than or equal to negative 2. Here's negative 2 here. I can put a bracket on that negative 2. All going to the right because it's greater than. And I'm going to have interval notation of bracket negative 2, comma, infinity with a parentheses. Number 16. Remember that's, I'm going to do it and look at it in the mirror, or the rule is to take the values that you have on either side of the inequality, flip them around as they are, x and negative 7, and then just take the sign and flip it so it'll be greater than. Okay, so now this reads x is greater than negative 7, so here's my negative 7. All the values that are greater than negative 7 are going to the right, this way, of course. And at the negative 7, I'm going to have a parentheses. So this ends up being parentheses, negative 7, comma, infinity, parentheses. Okay. Okay, for number 17 here, find the domain. That's all the x values. So you could, this is again going in the same pattern all the way, following this way. That's what's happening with this. So your highest amount would be this top here, which is 2. And the lowest is here, which is negative 2. So, well, take that back. Your domain first is going to be negative infinity to positive infinity. So let's write it as domain is, I'll do it this way, negative infinity to positive infinity. Okay. And it's the range that I'm speaking of here. The top, the highest it's can go in is 2. The lowest is negative 2. So therefore the range is negative 2, comma, positive 2, and you're going to have brackets around those. Number 18, similarly, your domain is going to go from negative 9 to positive 9. brackets again. Range is the same thing, only it's going to be -2 to +2 with brackets again. Alright, graph the piecewise function, so we'll graph these individually. So this is f of x. I want you to look at it as this. X plus 4. We're just going to graph this on the grid here. That's a 4, so I'll plug in 4 here. My slope is 1 over 1, so I'm going to go up 1 over 1. And the parameter is that f of x is less than 1. So this is this, and I got to use a dash line. Can I do a dash line here? I'm not sure. So I've got a solid line, but I'll make a dash line here. But it's all of them that's less than 1. So at 1, which I'm on here, this would be an open circle. Then your dash line. On the other hand, f of x equals 1. This is like y equals 1, so it's a horizontal line that if x is greater than or equal to 1. So at 1, it's a horizontal line, and I can use a solid line at that. So that'll go this way here. And this would be a closed circle. Okay, so look at it like that. So there's the graph, and we'll match it up to, which one is it? Looks like A here, right? It must be A. Open circle. There we go. So it would be A. Okay, and this last one, let's graph these separately. So this top one here, when x is less than or equal to 0, 2x plus 3, so I'll start at 1, 2, 3. 1, 2, 3. There's my first point. My second point using the slope 2, so I'm going to go up 2 over 1. And it's saying when x is less than or equal to 0. So here's my 0 here, so it's going to follow the line going down this way. Let me get my straight line. So it'll be something like this. I'm guessing, no, I don't want to do something like that. Alright, or I could go up to here and then use my eraser, but let's try it this way because it's less than 0. Okay. And that is a solid line. This next line is going to be a dash line. You know the problem I have with that. But it is at -4. Start here to graph that line. And I'm going to go up 1 and over 4. 1, 2, 3, 4. Up 1 over 4. And again, this is if x is greater than 0. So that means my line is going to go this way. And it's a dash line, however. So I need this back. So a dash line in between. Okay, you get the idea there. Ugly dash line. So this one I'm going to have an open circle here. And of course this is a closed circle with the equal sign. I'll leave that well enough alone there. And let's compare. Which one is it? And it is, looks like D, right? Looks like it might be D, not A. A you may be fooled by, but no, it's D. That looks good. Okay, there's the test for you.